Welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. If you're new to the channel, please subscribe and click the notification bell icon for future updates. Today we are going to talk about questions relevant for AWS Associate level certifications. We are now going to deep dive into some AWS questions. Let's try to understand the context and find right answers.
You are building an application that will collect information about user behavior. The application will rapidly ingest large amounts of dynamic data, so that the data is dynamic in nature, which requires very low latency. The database must be scalable without incurring downtime. What database would you recommend in this scenario? So you got like four databases, Redshift, RDS with MySQL, RDS with Microsoft SQL, DynamoDB. I will ask you to pause the video and think about the question, and you can write your answers in the comment. Okay, let's talk about Redshift as the first option. Now, Redshift uses EC2 instances. You need to choose. We are talking about dynamic data, which requires low latencies and rapidly ingest large amount of data. You cannot scale. So if you look at this, the scalable without incurring downtime. One of the requirement that you have to fulfill. Redshift is when you set up a Redshift, you define the EC2 instances on which your Redshift is running. First of all, Redshift is more about data warehousing, and it's not for any kind of day-to-day transactions. So Redshift over here, you have to define the compute capacity upfront, which defeats the purpose because you cannot scale. Moving on to the RDS with MySQL. Now, RDS with MySQL uses the same concept. It runs on EC2 instances, even though you don't manage it. It is again behind the scene, AWS is running it for you. RDS uses EC2 instances, and you have to change your instance type, size in order to scale. This is not going to scale in a dynamic way. Let's look at the third one, which is RDS with Microsoft SQL. Now, rapid ingestion of dynamic data. Now, dynamic data can change. So one record can be totally different than the previous one. So this data will change frequently. And as we know, Microsoft SQL is it's a RDB mesh, which means you have tables and you have rows, and it's very structured. This doesn't suit the dynamic nature. So this is another option that we cannot take. These three options, A, B, C, are not good. Let's look at the DynamoDB. Now, DynamoDB is a fully managed NoSQL database. That means it can support dynamic data. The other thing about DynamoDB is you need to provide read and write capacity, but in this case, as the nature of incoming data is not known, you can keep it on demand, which is one of the options that you can have for read write capacity that you have to define with each table, which means your DynamoDB will scale based on the incoming request or the read request or the write request. So this is the right answer in this particular scenario. Okay, let's look at the next question. A company is migrating from an on-premise infrastructure to the AWS Cloud. One of the company's applications store files on Windows File Server farm that uses distributed file system replication, DFSR, to keep data in sync. A solutions architect need to replace the file server farm. Which service should the solutions architect use? If you want to try this question, please pause the video, take some time out, think about the question, and write the answer in the comment section. Let's look into the details of this question. So a couple of things to notice. This is a window file server, and they're using DFSR. The important thing is they want to replace the file server farm, and this is on-prem infrastructure. So let's look at the bottom one. Let's start with EFS. What exactly is EFS? EFS is Elastic File System. Now, EFS doesn't support Windows. It only supports Linux systems. So this is not a viable option in this case. Let's talk about the second option, which is Amazon S3. Amazon S3 is not suitable in a way because Amazon S3 is storing objects rather than the file system, and it's not a replacement of what you have in the Microsoft file system. So you can discard this option too. Let's look at the AWS Storage Gateway. Now, if you look at the AWS Storage Gateway, it's a service that is primarily used to connect the on-prem to the cloud network, and then you can have kind of a sync between on-prem and cloud. So it consists of a software device that is installed on-prem and that can be used with SMB shares, but it actually stores data on S3. And it is also used for migrations, right? You can use it as a cache, you can use as a backup on the cloud. So this is not going to replace our requirement, which is in this case, the company needs to replace the file server form, and we need to have something that suits the cloud because they want to migrate to the cloud. They don't want to just keep the on-prem infrastructure and do a sync to the cloud. So this option doesn't suit well. Now let's look at the option that is most viable over here, and that is FSX. Now FSX, Amazon FSX, if you look at it, it is basically FSX for Windows File Server that provides a fully managed, highly reliable file system, file storage that is accessible over the internet using like the industry standard SMB protocol, which is Server Message Block Protocol. FSX is built on Windows Server, and it provides a rich set of administrative features, which includes end user file restore, user quotas, and ACLs, which is like access control lists. And additionally, like if you can say Amazon FSX for Windows File Server, it supports distributed file system replication in both single AZ or multi AZ deployments. And you can actually go to the service feature to find details about it. They will have a lot more information around it. So for this particular question, our answer should be Amazon FSX. Moving on to the next question. This question is about an Amazon VPC contains several EC2 instances. The instances need to make API calls to Amazon DynamoDB. As a solution architect, or a solution architect needs to ensure that the API do not traverse the internet. How can this be accomplished? Select 2. The requirement is that we have EC2 instances in a VPC and they need to talk to DynamoDB service. So how can we do that? Let's talk about few options over here. Let's go from option A. Maybe we can say create a route table entry for the endpoint. We need to select 2. So this looks like a viable option because how do we send this data is important. Amazon DynamoDB and Amazon S3 both support something called gateway endpoint. So you have a gateway endpoint. Now, using gateway endpoint, you can create an endpoint and attach it to the VPC. You can attach a policy that allows you to access the service and then specify that information in the route table, which creates a route from your VPC to these services. So creating a route table entry for the endpoint is looks like a good option. Now, second one is create a new DynamoDB table that uses the endpoint. It doesn't make sense over here. Why do we need to create a new DynamoDB table? We can do it with existing DynamoDB table. It is just a distractor, an unnecessary step that we don't need. Create a VPC peering connection between VPC and DynamoDB. So the VPC peering is, if you remember, VPC peering is between VPC. It's not between VPC and a public AWS service, because these services are sitting in the outside the VPC, and it is like in the AWS managed service, which are publicly available or global services. So this option doesn't make sense, because this one is a VPC and this one is a public service. That DynamoDB is a public service that is provided by AWS, so it doesn't make sense. Create an ENI for the endpoint in each of the subnets of the VPC. Now, ENI is Elastic Network Interface. Um, ENI is used by interface endpoint and not the gateway endpoint. So S3 and DynamoDB, they don't support the interface endpoint, and they were primarily using gateway endpoint. There might be a recent change. I remember there was something that they introduced, but till now, for this particular question, we can assume that there is interface, no interface endpoint available, and these two services only support gateway endpoint. So going by that particular logic, this option is wrong. Create a gateway endpoint for DynamoDB, which makes sense. So you create a DynamoDB endpoint, gateway endpoint, and you set the route table entry for those endpoint in your VPC, the endpoint that you created for DynamoDB, in order to route the traffic using the gateway endpoint that you have. Now, for this particular question, these two are the right choices. Moving on to the next question. Your company shares some HR videos stored in Amazon S3 bucket via CloudFront. You need to restrict access to the private content so that the user coming from specific IP addresses can access the videos, and ensure that the direct access via Amazon S3 bucket is not possible. How can this be achieved? Now, this is a very specific scenario, and this has been asked multiple times. And it is a pure representation where you have to put a policy in place so that your S3 bucket is not exposed with the public content that you're um, holding, or your distribution, which is a CloudFront distribution, which is reading through the S3 bucket. And the users that are trying to access your CloudFront distribution doesn't go directly from the CloudFront. Rather than going through CloudFront, they just go and get it from S3 bucket. So that's a problem that we have to solve. Please pause the video, take some time out to think about this question and look at the answers that we have. Okay, so in the meantime, let's talk about option. So configure CloudFront to require user to access the files using signed cookies, and create an origin access identity OAI, and instruct the user to log in with an OAI. So I was reading through this option over here. So configuring CloudFront to require user to access the file using signed cookies, create an OAI, and instruct the user to log in with an OAI. Now, OAI is something that user cannot use. OAI is an identity that is provided, that is attached to the CloudFront distribution, so that our S3 bucket understands that this is the identity that I have to serve. So that is only this particular identity that is attached with the CloudFront distribution is allowed to talk to that particular S3 bucket directly. So this option D, is incorrect here. The next one is configure CloudFront user to CloudFront to require users to access files using signed cookies and move the files to an encrypted EBS volume. This is a distractor. purely why will I move the file to an encrypted EBS volume? We are using S3 bucket where it is a kind of object storage, um, and S3 bucket is something that we can expose easily with CloudFront without having this extra step. You cannot use CloudFront to just pull directly data from an EBS volume. EBS volumes are primarily associated with EC2 instances. So in this case, how can you even pull that data? So anything that is coming with something like this, where you are given an option to pull from EBS while working with CloudFront, is kind of a distractor, and you can just omit that out. Configure CloudFront to require user to access the file using assigned URL, and configure an S3 bucket as a website endpoint. Assigned URL includes additional information such as an expiration date and time that gives you more control over the access to your content. And in that, you can actually specify IP ranges, IP addresses that you allow your users to come from. If you use CloudFront signed URL or a signed cookie to limit access to your file in your S3 bucket, you may want to prevent users from directly accessing your S3 file. In this case, by just going through S3 URLs. To achieve this, basically, we need to use origin access identity, which is basically a special CloudFront user that is associated with OAI with your distribution. So when you create a CloudFront distribution, you can add an OAI to that. Now, you can change the permission either on your S3 bucket or on the files in your bucket so that the OAI has read permission. Now, in this case, in option B, CloudFront requires users to access file using a signed URL, and the S3 bucket is having a website endpoint, but there's no mention of how. And um, in this case, like we still doesn't meet the requirement because you can still go and access S3 bucket directly if it is publicly exposed. So this option doesn't make sense. If you look at the option A, it says configure CloudFront to require user to access file using a signed URL, which is same. Then you create an OAI, which is a user associated with your CloudFront, and restrict access to your S3 bucket to the OAI. So your bucket is still public and it is exposed, but then the bucket is allowing access to only OAI user or the identity that is coming from CloudFront. So this option A is the correct option in this case.
This is the end of the show. Thank you for watching. If you liked the content, please like, subscribe, and press the bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.